Alright, let's take a look at my solution. Well, I load the MPG data, and after that, if I want to do a his plot on a MPG with the model year, and then I specify the alpha as 0.8, I want to make it a little bit transparent, and this is what I got. So it's the bars are only a little bit transparent, and if I don't want to specify the alpha and I do a histoplot, and it will be like this. Okay, so well, making the bars a little bit transparent doesn't really add anything because we are not showing overlapping plots. And here, well, I want to do the joint plot with the MPG on the horsepower and the MPG. Okay, so the MPG on the x-axis and the horsepower on the y-axis, and you are supposed to see something like this. And I'm using the scatter plot for this one. And if you want to do something different, and here are a few other choices. Okay, you can try them one by one and let me know which one you like the best. Well, personally, hexagons is my favorite. Okay, and then let's move on and play with another dataset. Well, you are going to see this dataset really a lot. That's the average dataset. Well, in the average dataset, we have 4 numerical columns: the sepal length, the sepal width, the petal length, and the petal width. And after that, we have a species. So we have a total of 3 species of the irises in this data, and for each species, we have 50 samples. Okay, so let's load this data, and then we want to do a pair plot. So for this pair plot, we are going to try to this visualization is able to show all the pairs, the distributions of all the possible pairs of the features in this dataset. And you can see there are 4 columns and 4 rows. So for each column, sepal length, sepal width, and the petal length, petal width. And then for each row, again, well, sepal length, sepal width, petal length, and the petal width. So well, for this one, this will be a joint distribution of the sepal length against sepal length. So we are only showing the distribution of one feature. Okay, and then we can see there are 3 different species, so there are 3 different curves. So for this one, we are only showing the distribution of one feature. And how about this one? So for this one, we are having the sepal length on the y-axis, and we have the sepal width on the x-axis. So sepal width and the sepal length, and then join those two together, we can have a joint distribution of those 2 features. And if you just want to observe those 2 features, and you may find that for the blue species, setosa in this case, well, this is really separable from the rest 2 species, right? So if we are only using the sepal length and the sepal width, and you can find, well, we can easily tell which flower is setosa because they are here and they are kind of separated to the rest 2 classes. Okay, and then if we want to use the sepal length versus the petal length, so that is this graph, petal length and the sepal length, and you may find that the blue species is even easier for us to separate. So it seems that separating or telling the difference between the blue species against the rest 2 species is really an easy job, right? And well, we can also see here. So this one, for this plot, that is the sepal length and the sepal length again. And if you this means by simply looking on only one feature, that is the petal length, and then we are able to tell if that is a setosa or not, right? Okay, so let's talk about the rest 2 species. Now we are worrying about the orange and the green samples. And if I ask you, if you have to pick one more feature that we can have the best shot to tell the difference, and then how can we do that? Well, if we only use one feature, and then our goal will be we want to look for the orange curve and the blue and the green curve. We want to see on which feature those two curves are most separable. Say for this one, they are kind of separable, but they overlap a lot. And for the second feature, the sepal V's, kind of the same thing. But for the last two, the petal length and the petal V's, and by using those two features, they are kind of separable, even though we can't do a perfect job. But if we have to pick one feature to separate the green species versus the orange species, and then I would pick the petal V's. Okay, so you may ask, why are we doing this? The point is, well, if we load this dataset and we want to do some machine learning, but even before we jump into any machine learning algorithm, you want to do some exploratory data analysis, which is called EDA. Well, and this this visualization, well, will give you some information on how good this data set is. You know there are three different species, and then this is likely to be a classification problem. Well, and then by visualizing the data, and you can tell, okay, for the blue species, that's really good. The classification can easily be done. And then for the rest too, the orange and the green species, they are not so good, but well, this is still kind of doable. So if we want to predict or have a feeling of the performance of the machine learning model, and you should say, okay, well, the accuracy with 85%, that's reasonable. Probably we can do even better, right? Okay, so let's move on, and we want to, before we do the next data set and the next visualization, and then we want to talk about the tips. Well, I don't know how many of you have worked as bartenders and waitress, and well, of course, and you are earning the tips, right? So for this data set, we have a tip data set. So you have the total bill and then the tip added on to the total bill, and then you will have the gender of the customer, whether that customer is a smoker or not, well, is that which day of the week it is, and then the time. And for the time, we have the dinner and then the lunch, and then the size of the party. Okay, so for this data set, the first thing I want to do is I want to add a new column, that is the tip percentage. So the absolute value of the tip doesn't mean too much, but we want to see what's the percentage of the total bill the customer give to the waiter or waitress as a tip. And then we want to do a FacetGrid. So for the FacetGrid, we are going to see a bunch of the histograms. And again, we are trying to separate the rows as columns. So for the rows, we are using the rows as the gender of the customer. So male or female. And then for the columns, we use them as a time. And remember, for the time, we only have two options. They are the lunch or the dinner. And then we use the margin title as true. And this margin title means that for the x and y axis, we are going to show what are the title of the time and what's the time, and then what's the gender of the customer. Okay, and this is what we got. So what kind of story can you tell using this visualization? For the lunch, is there a big difference between the percentage of the tip that given by male customers and the female customers? Probably no, right? Let me ask another question. For the lunch, so for the lunch, those two, well, do you see the difference between the customers, between the male and the female customers going to that place for lunch? Well, how do we tell that? That's the total height of the bars. So if you add all the bars together, so total height of the bars for the upper right and the upper left and the lower left, and then you will have the total number of the customers that are bless myself. Okay, so well, the point is, if you want to add all the bars to height of the bars together, and then you will have the total male for lunch and the total female for lunch. Okay, so you don't see too much difference between the male customers and the female customers, right? And then let's move on. So for the dinner, well, do you see the number of the male customers and the number of the female customers? They are quite different, right? So what's the reason? Why in the dinner there are more male customers than female customers? Probably because the guys do not want to go back to home and cook for themselves. Maybe. Well, but there's another option. Well, you see the size of the party. Well, it seems that for one record, it only records one person who paid the bill. However, in that party, it could be multiple people, right? So, well, it seems that even though, there could be male and female customers in the party, but usually that's the guy who paid the bill. So that might be another reason that in the dinner we see more male customers than female customers. Okay, and how about the distribution of the tip? So it seemed that, the majority of the tip, it doesn't matter it's lunch or dinner, the majority, the center of the percentage of the tip will be around 15%, right? So I don't see really a big difference between the percentage of the tip on the by the male and the female. Okay, so let's move on, and we want to do an exercise on the MPG data again. So we only keep the four interesting columns: the cylinders and the horsepower, the origin, the acceleration, and plus the weight. And then we want to do a hue as the origin. So we want to specify the hue, the the origin as the categorical feature. So remember, for the arrays, we are using the hue as a species, saying there are three different species, and we want to color those species differently. So now I want to move on and color the origin of the models of the cars differently. And then you can see there are only three. There are only three different versions, and the USA, the Japanese, and then the European. Okay, so let me use this one. Okay, so you are gonna show a visualization like this, and for each line and each column, there are the cylinders, horsepower, acceleration, and the weight, and we want to see the joint distribution. And for this one, we want to use a FacetGrid and showing the distribution of the origin and the number of the cylinders. And for the number of the cylinders, there's something interesting. And you see, there are cylinders as 3, cylinders as 5. Those are not the number of the cylinders I would expect to have until I see this data set. And the quite interesting thing should be which country or which continent produced the 3-cylinder cars and the 5-cylinder cars. And go ahead and make this visualization, and then you will be able to find out. And by the way, for this version, I used the old version of the Seaborn. And then, for the new version of the Seaborn, the default color got changed a little bit, so you are going to see this version and this version. So, when you're doing the coding, don't worry about the color. And then I'm going to stop the video here, and I will show you my answers in the next video.